Today we learn about physics. In physics, we learn about Newton laws. Before getting to the Newton laws, there are some types of forces. First, we can understand those forces. Coming to that types of forces, contact force, normal force, frictional force, forces exerted by a spring. Of course, there are the three types we can learn while we are discussing that force exerted by a spring, then weight. Okay, first we can understand what is contact force. Coming to that contact force, the name itself contact force. And a body, there is a body A and another body B is there. So they both are get contacted, and obviously A exerted force on B and B exerted force on A. So these forces are called contact forces. For example, if you assume that this is the A, this is the B. These two forces are contacted like this. Suppose this is this force B is pulling like this. This is the example of contact force. Otherwise, this force is pushing A. Is the example of contact force. Another example is there. Here, this push or pull exerted by a person. Another example is there, force by the wind. So we are experiencing that during the high wind situations. If you are walking on the road, there is high wind is blowing. Obviously, we can experience that high wind effect. So that is also called a contact force. Another example, force exerted by a load on the head of a porter. In railway stations are generally you can observe that porters they carry the luggage of passengers. So obviously the porters the luggage is put on their head. So that is also example of contact force. So this is called the contact force. Next force, normal force. The contact forces between the two bodies are perpendicular to the surfaces in contact. The forces are called normal forces. For example, if you take here, if you look at here, this is the one box. I mean, what I mean is, suppose, this is the one box. This is the another box. Suppose this is the fixed at the top. This is also fixed at the top. So they are perfectly fit in this two fixed surfaces. So therefore, what is happening here? This bottom of the block is exerted. This surface is this surface contacted. This surface and these two surfaces are contacted, and this surface is perpendicular to this surface. This surface is perpendicular to this one. This surface. This is perpendicular to this surface. This perpendicular to this surface. So therefore, whatever force is applied by this bottom block, that is perpendicular to this surface. Whatever force is applied by this block in the downward direction, that force is perpendicular to this bottom block surfaces. This is the example. You see that these two blocks. This is the two blocks. Top box A, that is A box. This is the B box. This box is they are. This is the fixed surface. This is the fixed surface. In between the two boxes are fit inside without any gap on the surfaces, so that this box is exerted force on this top box perpendicular to the surface. The two surfaces are perpendicular here. In this direction, this box is force exerted on this box in this direction. This is normal, perpendicular. This is the perpendicular. This is one example. Another example, you see here, this is the box. Suppose this is the box. This is the fixed surface. This is the box. At center of the box, if I applied a perpendicular to this at center, a perpendicular to this surface perpendicular, this is 90 degrees. and it is if you apply a force in this direction, this is also normal force. Normal force. Why it is normal? This force is acting perpendicular to this at center point of this surface. That's why it is also normal forces. These are all the examples. Obviously, so normal forces means that particular force is acting in perpendicular direction, in the perpendicular direction of the another object. They are called normal forces. Normal in the means perpendicular. That is the meaning of normal forces. Another force coming to that, the friction force. Two bodies placed in contact can also exert forces parallel to the surfaces in contact. Such forces are called frictional force, called force of frictional force, or simply friction. For example, this is also contact force. Let us assume that this is also contact force. This is object, this is the object, this is another object, this is the surface, plane surface, this is plane surface. Of course, these are all the contacted like this. Suppose if you apply force in this direction, the top block always is moving in this direction, which means while it is moving, if you are applying the force in this direction, this block is in this direction. At the same time, the bottom block, this movement of this top block is resisted because the surface is not freely allowed to the surface moving on this surface, because that force is called in this direction, that force is called frictional force. That frictional force is established in surfaces in the parallel direction. Before that, normal means perpendicular in this direction, whereas frictional force means in this direction. This is the block. If you apply in this direction force, so the surface is slipping over the bottom block of the surface. Obviously, this bottom block of the surface, it is not freely allowed to sliding the top box surface. So there in between, that force is established. That force is called frictional force. Of course, in our day-to-day life, we are experiencing. Suppose you are walking like this, surface, the ground floor, the floor is and the bottom of the leg and the floor. While you are walking, the frictional force is exerted. So this is the example of frictional force. Like any object, cycle or bike or any vehicle, moving on the road surfaces, obviously between the tires and the road surfaces, frictional force is established. Between those two objects, the tire, cycle or bike or train, whatever it may, whatever the object is moving or running or on the road, the frictional force is established. Okay, students, next one now. Next force exerted by a spring. A spring is made up of coiled metallic wire. It has a definite length. This length is called the natural length of the spring. The spring is pulled at the ends. The length becomes larger than its natural length. It is called extended spring. If the spring is pushed at the ends, its length becomes less than its natural length. It is called compressed spring. For example, if let us take this is the spring, this is the coil, these are the rings, Suppose these are the boxes are attached at the end of two ends. Let us you see here, this ends, the force is applied in this direction. Obviously, the spring, the coils is extended. Between the rings, the distance is extended, so that this length is greater than this length. You see that this is the length. Here. This length is greater than that. This length is greater than this one, because you are applying, the force is applying away from the spring, or pull either side of the spring, so this length is greater than this one. But the change is, you can observe here, this is the coil length, maybe the coil between the these rings, the distance is increased. Again, suppose the spring is pushed either side. This is the pushed like this, the force is applied in this direction. This the ring between this length is decreased, these are closed, these rings are closed, coming to close. So this length is less than this one, original length. This length is less than this length. So this is a natural length. So the force exerted by a spring. So this type of observations we can observe in the spring. Let us take this in pens. You can see that this type of spring is used obviously. So in pens, obviously we are this is the natural length. Of course, this is the natural length. The pen is pushed like this, opened like this. The spring is pushed, compressed. You see that this is the original length. If you stretch, if you pull in this direction, force, this is extended. This is called extended spring. Suppose the force is pushed like this. This length is decreased. The rings are the close one to one, closing to the length is decreased. So this is the force exerted by the spring. Force exerted by the spring. Another one, force exerted by a string. Next force, the force exerted by a string. And when an object is tied to a string and the string is kept taut, the string pulls the object. The string pulls the bottle in the upward direction. The magnitude of the force extended by a string on the bottle tied to it is called tension. If you see that this is the string, here some bottle is suspended here. Obviously that this is the string. This is the fixed here. The string is the string is suspended by the bottle. So without bottle, let us assume without a bottle. Okay, that string is the string is attached by this connected by this bottle. Obviously the string length is increased because of this bottle. Of course that the string is subjected to little bit extension, but the string is try to pull this bottle in upward direction. This bottle is pull it in downward direction. The string is pull it in upward direction. That bottle is pull it in downward direction. Of course, because of that more force than the string, the length of the string is increased. So that is called, that string is under tension. This pull it in this direction. So the string is under tension. This is under tension. Pull it in this direction. So this is the force exerted by a string.